Completing the square is a process which is kind of difficult to understand, so I'm going to go through an example or two showing and explaining all the steps, hopefully making it clearer. So let's start off with an example that doesn't need to have the square completed because it is already complete. Here is a perfect square. X plus 3 squared, of course it's a perfect square. There's the squared right there. If something is squared, it means you're multiplying it by itself. And when you have a expression like this, you can just expand it with FOIL. First, x times x is x squared. Outside, x times 3 is 3x. Inside, 3 times x is 3x again. Last, 3 times 3 is 9. Combining like terms, the two 3x's become 6x. And so this is a perfect square. This is a perfect square. You can recognize a perfect square when it has this pattern. This central term is double of the square root of the last term. The square root of 9 is 3. 3 is half of 6. Half of 6 is 3. 3 is the square root of 9. That is a perfect square. Now, let's see if we can recognize how that works in reverse. Is this a perfect square? Well, in order to answer that, we just need to know what's half of 8, and is that the square root of 16? Well, half of 8 is 4. 4 squared is 16. Yes, this is a perfect square. So let's just work out how that could have been. This 8x is just 4x twice. This x squared comes from x times x. This 4x comes from x times 4, and this 4x comes from 4 times x. And that 16 comes from 4 times 4. Well, this is just x plus 4 squared. Okay, so these are both examples of perfect squares. No need to do any completing. We're just looking for the pattern of half of this is the square root of that, or the square root of that is half of this. Completing the square is what you need to do when this pattern doesn't hold. So let me erase this side, and we'll put on a different version. Okay. Just a second ago, I had written here x squared plus 6x. Now, what was supposed to come next? Half of 6 is 3. 3 squared is 9. But what if 9 isn't here? What if instead of 9, I have 8? Well, 8 is not 9, of course. So how can I factor this or express this to look differently? Well, here's a way to do it. If I were to add 1 and then immediately take away 1, I haven't actually changed anything. This is still x squared plus 6x plus 8, because 8 plus 1 minus 1 is still 8. Nothing has changed. All that has changed is the way that it looks. It's kind of like turning 1/2 into 2/4 It's still the same thing, it just looks different. Now, why would you want it to look different? So that it can fit into certain patterns, like getting a common denominator is helpful if you're adding or subtracting. I want this to be a 9, or at least I want to be able to see a 9 there. If I were to take x squared plus 6x plus 8 plus 1 minus 1 and rewrite it, I could have this. X squared plus 6x plus 9 that's 9 minus 1. Now this is still x squared plus 6x plus 8. It just has a 9 in the writing that I can use because this is that. And this stays. If you were to expand this square, x plus 3 squared, you'd get x squared plus 6x plus 9. That minus 1, still here, and when you put that minus 1 with that 9, you get the 8 that we had at the beginning. That's completing the square in a nutshell. Something that is not this perfect pattern, but is close to it. Just change this into a modified version of the perfect pattern. Factor the perfect part and leave the change outside. That is completing the square. Now, it is a square, and that is both algebraic but also geometric. I'd like to show that to you. X plus 3 might look like this. There's x. 1, 2, 3. This is x plus 3. X plus 3 squared would be length times width. There's x. 1, 2, 3. X plus 3 squared would be the area of this square. So let's find out what that is. This is x by x. Right there. If I bring these down, okay, I've got some rectangles. What are these? Well, this is x, and this is 3. This section right here is 3x, and so is this one. There's x, there's 3, 3x. There's both of the 3x's. Now what does this look like? It looks like tic-tac-toe, because this is 1, 2, 3, 4, 5, 6, 7, 8, 9. There it is. Now, what would x squared plus 6x plus 8 look like? It looks like this. x squared plus 6x.
1, 2, 3, 4, 5, 6, 7, 8.
Do you see the piece missing? That's the one missing piece. If you were to take x squared
Plus 3x.
plus 9 and minus 1 from it, you end up with x squared plus 6x plus 8. Okay? Completing the square geometrically looks like either a square with a chunk missing,
In which case it's
something else on the outside,
I'm sorry.
taken away from the outside,
Or
it's a little extra piece there. Now it's time for the plus sign. It is up to you to identify in an equation like this its resemblance to the perfect version, but with a modification. Algebraically, that's what that looks like. Geometrically, it would look like looking at this thing and recognizing it's almost a square. It's just got that one little extra thing hanging off, or it's missing a corner. That's completing the square.